This is a NEET 2019 question on oscillations. Question is like this. A mass falls from a height h and time of fall is t, recorded in terms of time period t of a simple pendulum, capital T, on the surface of the earth, and the relation is t equal to 2t. I'll stop there for a minute and try to solve what he has given on the first part of the data. A mass m falls from a height h. I can use a formula S equal to ut plus half at square. As it has freely fallen, initial velocity equal to 0. S is h, ut becomes 0. A is plus g because it's falling on the earth, t square. So the t, what he is saying, t is equal to actually root 2 h by g. That is this t he is talking. Next he is saying, in terms of time period of a simple pendulum, we also know that, and the time period of a simple pendulum t equal to 2 pi into root of L by G, where L is the length of the pendulum. And the relation between them is given that small t equal to 2 into capital T. I know small t, I know capital T. Let us square this equation. 2h by g equal to 2 square is 4, 2 pi square is 4 pi square, square root of L by G becomes L by G. So this G and G will cancel. This 2 and 2 will cancel. So H is equal to 8 pi square L. That's one relation I have got basing on the first sentence. I have read the problem until this part only. I got some understanding. Let's go to the next part of the problem. The entire setup is taken on the surface of another planet whose mass is half that of the Earth and radius is same. So let me go to that part of the problem. When it is taken to other planet of mass m by 2, radius same, acceleration due to gravity changes. Relation between them is equal to g equal to gm by r square. So g dash is, capital G is constant, universally gravitational constant. Mass became m by 2, r remains same. So the g dash has become g by 2 in the second part. So I have to consider g dash as g by 2. The same experiment is repeated and the corresponding times are noted as t dash and capital T dash. What does it mean is actually when experiment is repeated on other planet, I have to take g dash equal to g by 2. For a free fall, I can write a formula h equal to half g dash t dash square. That's what the equation is, right? Half g dash t dash square. So t dash equal to root 2h by g dash. That is root 2h by g by 2. That equal to square root of 2 into 2h by g. That is new t dash. T is this, but t dash is different as he has mentioned. And there is another part of the problem. And for the simple pendulum on the planet. M period dash can be written like this what I am writing on a new planet. 2 pi into length of the pendulum is same, but g is different, that is g by 2 as we have proved. So t dash equal to 2 pi into root of 2l by g. If that is the case, I want a relation between t dash, small t dash and capital T dash. What I can do now is, in the place of small t dash, that is in this equation t dash, in the place of h, I have derived some relation h equal to something, that's a relation between h and l. I will substitute that, therefore I will get it in terms of capital T dash, right? So let me write that as T dash equal to root of 2 into 2h by g, and h equal to what I have derived is 8 pi square L. Substitute that. T dash becomes root of 2 into 2, this 4 by g, in the place of h, 8 pi square L. So I can write this as square root of, I have to write it in these terms, right? 2 pi into root of 2l by g is t dash. So I have to see how t dash can be expressed in terms of small t dash can be expressed in terms of capital D dash. This 4 I can get it out of the root, it will become 2. This pi square I can get out of the root, that becomes pi. So if I write that 4 pi square out of the root, it becomes 2 pi. What is remaining is 8l by g. So this is 2 pi into square root of, I have to write it in these terms, 2l by g. So I can write it as 4 into 2l by g. Now I can write this 4 again outside into 2 pi root 2l by g. But I know 2 pi root 2l by g as per the given problem is t dash on the new planet. So what I am going to get is this 4, okay, I have to get out of the square root. Be careful. I am getting this 4 out of the square root. When it comes out of the square root, it becomes 2, not 4. It is under square root 4, so it becomes 2. 2 into 2 pi into root L by g is nothing but t dash. So the new free fall on a planet, t dash equal to 2 times of new time period of the simple pendulum. So t dash equal to 2t dash is the relation that we are supposed to derive. So it may look like a lengthy problem, but it's not actually. But there are multiple concepts involved. Concepts like variation of the g with respect to mass that need to be known on a different planet. For a freely falling h equal to half gt square, a basic formula. Time period of a simple pendulum 2 pi into root L by g. With this basic data, if you just navigate through the given information, you will come to the answer comfortably. That's how you have to solve, right? Thanks for watching.